So Ohm's law actually looks at the relationship between voltage, current, and resistance, right? These are the ways that they are shown in a formula. So the formula is V is equal to I times R. So one way of being able to think about this is just logically, right? So if the push of V is stronger, then the charges will be able to move faster, right? It's like me pushing things down a hill. The faster I push, the harder I push, the faster they'll be able to go down the hill. That's the relationship with this. So as V increases, I will also increase. Another way of looking at it is the more push I have, the more the charges can do work, right? So it has more of an ability. So think about blowing on a windmill, right? If I blow on it really hard, I can actually get a larger windmill to move, or I can get my windmill to move faster. So this relationship, as my V increases, my R increases. Another way of looking at it is from the resistance point of view, right? So if I increase my resistance, the current will decrease because it's like pushing a really heavy door. If I'm making everyone pass through this rotating, this revolving door, and the revolving door is really hard to push through, it's going to slow the number of people that can get out of the building because it takes so much work to push. So increasing R will decrease the current. Or another way of saying this is if I increase R, the amount of push that is needed in order to get through the same number of people will have to increase. So if I want the current to stay the same, the number of people to get through to be constant at a certain rate, then each person is going to have to push that much harder in order to get through that heavy door. The reason why I'm not looking at current is really that voltage and the resistance are the things that you control. You either control how much push you give to each of the charges, or you're controlling how much work energy you are getting out of those charges at the resistor. What happens to the current is then a consequence of what we do to the voltage and to the resistance. So because the example I have here, example A, is how much current would be generated if a 60-volt source that powers a vacuum cleaner has a resistance of 20 ohms. So the vacuum cleaner has a resistance of 20 ohms. I'm plugging it into a 60-volt source. It could be a battery, it could be a wall socket, whatever. So I use the equation V equals IR. I rearrange it to solve for I, and then I plug in my values, and I solve and add my units. So V is equal to 60, R is equal to 20, 60 divided by 20 is 3, and the units of current are amperes, or capital A. And then B, I'm solving for voltage. How much voltage would be required to power a motor of a resistance of 25 ohms with a current of 8 amps? So you need a certain amount of current. I have 25 ohms worth of resistance. Again, I plug it in. I don't have to rearrange anything because I'm solving for V. I plug my values in, 8 for I and 25 for R, and I solve and add units. So that ends up being 200 volts. So this might be one of those instances in which you want to power a device. You plug it into a battery or a generator or something, and nothing turns. It's not that the generator is broken. It could be that the voltage that you require in order to power that device isn't what your power source can provide. And so nothing happens. So it's not like you could have a situation in which it kind of weakly does whatever, like the bulb weakly glows or something like that. Or it could just be that it's an all or nothing thing and nothing happens, like your engine just doesn't start. So these are quick examples of how we can use that V equals IR equation, and we'll be using those in our circuit calculations. Basically, that's all we use.